Get them out of there.
Start yelling at them too.
Ooh, start talking. 3. You have to make your drum major a spectacle.
Let's take a quiz Friday.
Stop that.
Good day, Daisy. We'll be on projectile motion. Quiz Friday on projectile motion. You get that, Connor?
What is in like the live chat right now?
What?
Take a guess and say it's not.
Right. Yesterday we left off shooting cannon.
Yes.
Tomorrow we're gonna shoot cannons in the classroom. They're spring loaded, sorry, no gunpowder,
Can
but
we do pirate voices while we shoot?
sure.
Sure. Shoot them at each other.
Do not shoot them at each other. Well, I mean, don't shoot them at each other in a way that I would be aware of. Or anyone gets injured. All right, so remind me, what did we shoot the cannon? What was our initial 200?
Yes. 225 degrees.
25 degrees, okay. So we want to know all the normal things that they're going to ask about. We're going to want to know this maximum height. Stay right along in there, okay. All right, so that's going to be, call that 8 if you want to, which is going to turn out to be delta y, that particular location. We want to know the range, delta x, and we want to know the time of flight. T. That's about it, isn't it? We're going to make the assumption here that our delta y is 0. So from here to here, what's the range, time of flight, assuming delta y is 0. In other words, we're going to ignore the fact that the cannon, the end of the barrel is a little bit off the ground, right? So it's technically dropping a half a meter or so. We'll ignore that for now. The first thing we have to do is get this initial velocity into an x and y component, because we have to treat all projectile motion problems in separate dimensions that are linked by the time. So our initial velocity is 200 meters per second at 25 degrees. We want to know our initial velocity in the x direction and our initial velocity in the y direction. We need to find those two values. So we're going to be trigonometrists here for a minute. Is that a thing? Trigonometrists? All right, so the sine of that angle is going to be VOY over V, opposite over hypotenuse, right? And the cosine of that angle will be VOX over V, adjacent over hypotenuse. Correct? Like that. Okay. All right. So that means that VOY, initial velocity in the y direction, is V times sine theta. VOX, which is initial velocity in the x direction, is V times cosine theta. So this is 200 meters per second times the sine of 25 degrees. This is 200 meters per second. What's the cosine of 25 degrees? 84.5. $181. Agree with that? Okay. All right. The X direction, also known as the horizontal. Okay. We have a couple of facts. One that's important is A equals 0. Okay. It's not going to accelerate in the X direction because we are assuming that there's no air resistance. Okay. You watch the opening kickoff Friday night. Okay. We got a pretty good kicker. Alexander's got a little kid that can boom it. Okay. Cleat. Yeah. What a name for the kicker, right? I mean, who thought ahead on that? You know? When he kicks off Friday night, okay, that ball's not going to be perfectly parabolic. Because when it gets into the air, it's going to start off looking parabolic, but it's going to hit some air resistance. Okay, if there's no wind, it's going to hit some air resistance. Okay, and it's going to look more like that. Okay, it's going to taper off at the end. If he was to kick off with a tailwind, it might look like that, right? If he kicks off into the wind, it might look like that, right? So in other words, when they kick off Friday night, their ball will accelerate in the X direction, okay? Due to be pushed by the wind, pulled by the wind, something, okay? But our cannonball is not doing that. Okay? So we don't have any acceleration in the X direction, so this is going to travel in a symmetrical parabolic trajectory, okay? Which means the only equation that we deal with here is the velocity initial. If this is 0, the initial velocity in the X direction is equal to the final velocity in the X direction because it's never going to change, right? So we have this equation. Vx is delta x over time. So at any point along that trajectory, this equation is true. Okay? Any point along the way. In the y direction, also known as the vertical direction, we have 3 equations. First, let's point out that A will equal G, which, since we're shooting this cannon on the Earth, is 9.8 meters per second squared. The final velocity in the y direction will equal the initial in the y direction plus G times the time. That'll be true at any point along the trajectory. The change in the y will equal the initial velocity in the y times the time plus half of G times the time squared. You could write that the way we wrote it over here, because that's the way they write it on the. You make delta y x equal x0, that annoys me. Anyway, it's fine. I swear they do that to make it complicated. Right? Or we've got final velocity in the y direction squared equals initial velocity in the y squared plus 2 times gravity times the displacement in the y direction. All 3 of those equations apply at any point along the trajectory. at any given point, the time is the same for both dimensions, right? Okay. So in other words, if we wanted to know stuff about it at that point right there, okay, the time it took the ball to go from here to here, and the time it took the cannonball to go up and back down to there, the same times, right? We're interested in 2 points here, this one and this one, okay? Okay, so right, let's start with this maximum height. If I throw this pin straight up in the air, what did it do before it came back down?
Stop.
It stopped. At its maximum height, its velocity was zero. So at this point right here, that point right there, Vy equals 0. Okay? So if we want to know delta y at that point, we've got two choices, this equation, this equation. This one requires us to know the time. We don't know that yet, right? This one doesn't, okay? So if we know that the final velocity at that point is 0, and our initial velocity is 84.5, and we know g, we can solve for y, right? So let's pull this out over here for a minute. So we're finding the max height. Delta y, initial in the y direction. No, it's not. Wrong equation. Final velocity squared is initial velocity in the y squared plus 2g times displacement in the y direction. At this point, that is 0, right? So 2g change in y is minus VOY squared. So delta y, which is going to be equivalent to the height, is minus VOY squared over 2g. Physics gets easier when things are 0, right? Things start to disappear from the equations. I'll get out of the way in just a second. This is 84.5 squared over 2. Don't lose track of your negatives, because if we don't have a negative in the numerator and the denominator right there, we're going to end up with a ball that somehow went underneath the ground. Right? So negative delta y would mean we shot it in the dirt. All right, so where that comes out today. We got 364. Huh? Pretty high. That is 364 meters.
The one square must go that far.
No. It might go 3.64 maybe on a good day. Probably not that. Everybody good with that? I like it.
Yeah, put parentheses. Not squaring. Oh.
All right, now, range or time of flight, doesn't really matter which one you do next, okay? It doesn't matter. Get the range, we've only got one equation that will give us that, right? Okay, so we know the Vx, we gotta find T. So we need an equation over here. It's got T plus other things that we know. This one has T, and we can use this one because this is zero, right? Doesn't matter if it's not zero. All right, we can use this one. We know we don't know our final velocity in y direction, so we don't. So we have to use this one, okay? Now, to find T here, delta y is zero is pretty simple. It's not quadratic, right? But if delta y is not zero, then it's quadratic, which we derived all that the other day, right? So we wouldn't have to do it again later in the middle of a problem, because it's just like 10 minutes out of our life we won't get back every time. So we got that written over here, okay? But we won't need this as long as delta y is zero. Delta y will not always be zero. It is in this problem. But if it's not zero, then this turns out to be a quadratic formula situation, okay? If delta y is zero, then we can cancel out some t's, okay? So let's just do that right quick. Delta y is a zero, right? So zero equals uyt plus half gt squared, okay? So here's how we're going to get rid of the quadratic part of this. Quadratic meaning we've got a t and a t squared, right, in the same equation. Since this is zero, I can just divide everything by t. It's legal in algebra to do anything you want as long as you do it to everything, right? Correct? What's zero divided by t?
Zero.
Zero. What's these two t's going to do? They just canceled out, right? So this became v zero y. What's this t going to do with one of those t's? Cancel out, right? So this just became half gt. Physics is really easy when things are zeros, right? When none of it turns out to be zeros, it's not difficult, it just takes a little longer. Because you have to do things like quadratic form. All right, so half of gt will equal negative initial velocity of y. So t will be negative 2 VOY over g. Some algebra there. So the time of flight, start finish, negative 2 times 84.5 over negative 9.8. $17.2. Yep. Okay. So we've got a maximum height. We've got a time of flight. How far did it go? That's delta x. Okay. Now, just plug in that number for t. You could plug in this equation for t. Doesn't make a difference. It's all the same thing. This is 181. 17.2. How far can the ball travel? Little 3,000 meters. Almost a mile, not quite. 3,200 meters is right at a mile. No, that's 2 miles. Sorry, 2 miles. Yeah, 2 miles. Yeah, 2 miles. 1,600. All right. I like it. How long did it take it to reach the maximum height?
We're gonna have that silence.
8.6 seconds.
What?
8.6 seconds.
Half of 17.2? Everybody see that? Because it's a symmetrical trajectory, right? So it's going to be halfway. It's going to be at its maximum height, half of its range, and half of its time of flight. So the max height would occur at a range of 1,555 meters.
Yes.
Half of that, right? And a time of 8.6 seconds. All right. Questions? All right, that's a pretty general problem. Now we can make all kind of alterations to that. We can speed it up, slow it down, change the angle. Biggest thing we can do here differently is we could change the delta Y. We could shoot this off of a cliff. We could shoot it from the ground to the top of a cliff. So we could have a delta Y that's either positive or negative, depending on whether the cannon's at the bottom or the top of the cliff, right? Another popular question with this is to shoot a projectile and try to figure out if it's going to cross a particular object or not. If it's basically a field goal kick, right? So you kick a long field goal, right? It's not so much important how far it goes, it's how high is it when it reaches the crossbar, right? Which is not its complete range, correct? But if you kick it too low, as they say, it may have the distance but not the height to be over the crossbar. That makes sense? So there's a physics problem in that. So if we pull up something like that and work it, so we find in our practice problem over here. If I start trying to make these problems up on my own, they don't work out very well. So we end up kicking it out of the stadium or something like that. That makes sense. So that's super clean. Yeah.
That's where people put like buttons into baseball bats, play baseball bats and ball just goes like hundreds of miles per hour. That's awesome. Now imagine it's so good that's really like good. There's like the same guy made a basketball hoop that like follows your shot.
Oh. He made 2 or 3 versions of that before he made it like move in all directions.
Yeah, essentially he sets it up on like a set of pulleys, so it's able to cover like the length of the wheel, like will move where your shots are. You have to get like computers like 6 basketball.
Yeah, it's like a motion sensor camera, and it'll see where you throw it and like predict calculate where it's going and it'll move it. He destroyed many things doing it because he would have it moving at such a high speed that it would like fly into a wall or something.
I watched another YouTuber flying pressure washers.
I saw that.
It was sense. That's loud water. The same guy.
Which, the flying with pressure washers, that's just like these little, like, jetpack things that they got in Florida, where it just like shoots you out of the water.
I want to try one of those things so bad.
The same guy put a blank inside a pool stick so he could play super pool.
Oh,
See, the thing is, a pool stick isn't durable enough to handle the energy of a blank, so like he would use it, just like essentially.
y'all seen that picture of the guy who killed a wasp with ranch?
No.
You actually haven't seen that? He dumped a whole bottle of ranch on one wasp to kill it.
I've seen a video of like a guy like taking down a fly and he's like removing the seeds from the dragon fruit.
All right, this is number 22, on page 69. I'm not gonna turn the camera on because I'm in the projector on, I'm directly on the board. Everybody good, what's on the board? Can I erase it?
Oh, guys.
Number 22, you said?
Yeah, page 69, number 22. Got it, book, it's not on. I'm gonna add a little question to it. How much time have I got? Mastery day, right?
25, well, yeah, that will be 15 minutes.
9:02. Yeah, okay.
Simple addition.
Whatever. I forgot Mastery Prep. Mastery Prep is stupid.
We didn't even have that street prep anymore. Where did we go?
We had senior meeting,
Is that in the lunchroom?
You don't have a senior meeting every Wednesday?
apparently.
They're bringing in speakers to talk to us.
Oh, really?
about their
I
jobs.
thought it was like still in Father's Day. This week.
That was last week, I think.
That last week we went to a. You weren't here, don't question it.
No, I was here last Wednesday. I was out,
Alright,
wait. No, I wasn't here last Wednesday.
we're kicking a football right here. Ground level, 18 meters per second, 31 degrees. How much later does it hit the ground? Okay, that's what they're asking. So how much later? That's time, right? Correct. Okay. Here's what I want to know. I want to know delta x and delta y equals 10 feet. So then convert that to meters, right? Because goalpost is 10 feet high, right? So in other words, from what distance is this a good field goal, assuming it's kicked straight, right? So convert that to meters. And then when you get your final answer, you'll need to convert that back to yards so that we American people can understand what we're talking about.
You said you want us to convert to yards?
Well, meters solve the problem. You gotta put 10 feet in the meters.
Yeah.
In order to match up with 18 meter per second velocity and all that.
Do you
And
need
we
to
finish the range, put it back in yards so that we can sort of relate to it as far as like spectating at a football game, is this a good kick or not?
time of flight. So I was 5286 instead of. It's not my numbers, you just like it. Ideally, it shouldn't be too much. This problem makes me want to switch us over to the metric system. Yeah. Well, because we want to find what the kids are, so it's otherwise it could be zero.
How we doing? How many meters is the 10 yards? 2.9 or something, 3.1? 3.1.
3.03.
3.
Okay.
All right, so first off, what's the time of flight?
Okay, 1.9 seconds.
For the whole thing, right? We've got a delta y of 0, correct?
Mhm.
We're looking at the ball being kicked and coming back to the ground, right? Am I with me on that? Okay. So when delta y is 0, well, first, I skipped a step then, all right? We gotta resolve this in their components. This is 18 meters per second. 30. At 31 degrees. What do we have for x, which I'll get? X velocity.
15.4.
Yeah,
How much?
15.4.
15.4. Everybody good with that number? I know where it comes from. 18 times cosine of 31. What's this y component here?
9.27.
How much?
9.27.
9.27. Okay. All right, so delta y is initial velocity in the y direction times the time plus half g times time squared. That's 0. So we can divide everything by t. Same thing we just did a minute ago, right? So we're going to end up with half of gt equals negative initial velocity in y. So this is negative 2 VOY over g. So negative 2 times 9.27 over negative 9.8. How much is that?
1.9.
1.9 seconds. Okay. Pause in the air for about 1.9 seconds. Okay, now, what's delta x when delta y is 3.03? Okay. So what's going to link the x and the y together? Time. So we need to know how much time has elapsed when the ball is at a height of 3.03. We're going to get two answers. You picked up on that yet? It's going to pass through this point somewhere over here and over here, right? The logical choice for making a field goal, right, is, well, there could be two, maybe. but the second one, right? Okay, so, let's see here. Still using this equation, but now it's quadratic. So delta y is b0 yt plus half gt squared. Delta y has number now, 3.03, right? Same initial velocity, same g. So now we got to solve for time using the quadratic formula. So let's cheat here and use this over here for a second. All right, so the time will equal minus the initial velocity in the y direction plus or minus the square root of the initial velocity in the y direction squared plus 2g delta y all over g. Right? Just altered that to match y direction stuff, free fall type stuff. All right, so this is minus 9.27 meters per second plus and y'all see where we're going with this?
Yeah.
Okay, keep going. You're going to get 2 times. Okay, quadratic formula gives you 2 answers, plus and the minus. Okay, these should both be positive numbers. Okay, then you're going to find the range. You can find the range for both times. That's the first time. The low number range is the first time it reaches 3 meters, right? And the second number is the second time it reaches 3 meters. If you're kicking a field goal, right? The second time it reaches 3 meters, that's the maximum distance that's a good kick, right? Okay. So figure that out. For the fun of it, change your final answer back to yards so we can think about it tomorrow. Mastery prep, right?
I need to know how many meter and meter.
I put it from being minus.
Yeah, see, that's an annoying way. Just Google how many meter in a meter. And then just go straight to the
The only ratio I know is from mile to kilometer.
oh, it's 60.
Mastery prep day.
Oh, I'm so sorry.
No problem.
My mind didn't.
Mr. Cato, is there some video I can watch in particular to understand it better?
Khan Academy should have something. I'll look and see, make sure that you look at that too. Just projectile motion, Khan Academy. Be the first place I would look. You too. Hey, what's up? You ain't gonna believe this.